All right, hello everyone. Thanks for coming out. Today we're going to be talking about programming foundations in C Sharp. So what does programming foundations mean? That means we're going to be talking about the basic syntax and building blocks of programming. Now this is the first lecture of 2 for the programming foundations course. So we're going to go over the first half about through lesson 15 of programming foundations, touching on some of the most important key points that I picked out. So to get started, when we're writing C Sharp, you're going to be using an IDE such as Visual Studio or VS Code as an editor. So I'm going to be using Visual Studio. I'm going to go ahead and create a new project. And save this in here. We're going to make where is it, console app. All right. Let's go ahead and run this real quick to make sure it has a console that comes up. There we go, good. The console came up and then it closed out. So if we do a console.read line, that should hold it open for us. Run it again. So there's our hello world when I created a new blank app. So that's just to make sure that this is working. We're ready to go. We're going to start by talking about comments. So when you're writing code, sometimes you need to leave a comment to help other people looking at the code or yourself looking at the code when you go back to edit it know what was kind of going on there or a thought that you may have had. It's to help kind of narrate the code. There are a few ways to do comments. The most common one is just 2 forward slashes, and then you place your comment here. So this will print hello world to the console. So there's a comment that is explaining what that's doing. I might add another comment here. Keeps the console open until user presses enter. Now that's what it's accomplishing here. That's not exactly what it does. It reads user input and provides that input to the application. So that's the first way to create a comment. A comment is just text. It doesn't get executed. The compiler completely ignores it, and it doesn't affect anything. So you can put anything you want after your forward slashes. It's just for human use to look at and know what's going on. So another way that you can create a comment for a multi-line comment, because if you notice, if I go here and then I start typing, it's back to code. It's going to underline it. It's incorrect. So if you have a comment that spans multiple lines, instead of doing this, you can do forward slash asterisk, and then asterisk forward slash. So there's your multi-line comment. Right, so just like that. A couple things about comments that are very important to recognize when you're coding is don't rely on comments to tell someone what your code does. You shouldn't be writing comments that explain ambiguous code. You should write your code in a way that it's not ambiguous. So what that means is we're about to talk about variables. But what this means is you should name your variables and name your functions and methods with names that make sense. For example, if I have a variable called, well, let's say it's a string, and I call it name. Well, what does that mean? When you look at that, you know, well, it's a name. Well, that could be the name of a city, that could be a person's name, that could be a pet name. It doesn't really tell us much about it. So don't be scared of a few extra keystrokes in creating a more explicit name. So I could say first name, and that's better. I know it's a first name. It's probably going to be the first name of a human. But also we could have something like charge. This could be of type double. We'll talk about types in just a minute. But what is charge? I'm going to assume it's a charge for something. Maybe someone bought a candy bar. Maybe someone you know, took the stuff out of the fridge at the hotel. You really don't know. So if I want to be more specific, I could call it hotel concessions charge. That's pretty specific about what this variable is. That way, when you're writing code, people can see exactly what you're doing without the need for notes. Now, that doesn't mean you don't have to or you can't use notes. That just means you should never use comments to do the job that should be accomplished by clearly named variables and methods. So just keep that in mind as we go throughout this. So let's start by talking, well, not start, we talked about comments already. We're going to talk about variables now. So a variable it's like a bucket. We assign it a name, and then you can assign a value to it. A variable is how we hold our values, and we can move data around. If you think about algebra, a lot of times you have like an equation like y equals mx plus b. Each of those is a variable for a specific value that can be plugged into that equation. Variables in programming are very similar. Another way to think about a variable, besides a bucket that you put a value in, is if you think about people, and you say, if I show you a picture of a bunch of people you don't know, you can't really tell me who they are. It doesn't mean much to you. But as soon as I give you a name to that face and you say that name, you can see that name is connected to an individual. So that name is a variable, and the individual is the value that's assigned to that name or that variable. So when we're creating a variable, there are three main parts to it. First off, you have the type. Type can be anything like, is it text? Is it a number? Is it Boolean, true or false? So that's the type. And there are multiple different types. We'll cover a few of them. And then you're going to give it a name. That is the name. That's the identifier. Just like a person has a name, a variable has a name. So when you refer to that name, you're referring to the value that it holds, which leads us to the third part, is the value. What is that variable pointing at? So for example, if I have an integer, the name is age, and then I can assign a value to it. So I've got name or type, name, and value. The type is an integer or an int, meaning it's going to be a whole number. The age, that's the name, and the value is 37. So now anywhere that I refer to age, that will be interpolated in a manner with the value. So just so you can see, console dot right line age. And let's go console dot read line to leave that open. So I put age right here, and see how when I highlight that, it highlights the age up here. It's showing that it's the same variable. So when I print out age, what happens is it prints out the value that age is identified by. So let's go ahead and save that and run it. And you can see that it prints out 37. So to talk about another type, we have string. A string is a text-based data type. It's a string of characters. A character is like A, B, C, D, 7, 8, asterisk. All those are characters. And when you string a bunch of them together, you get some text. That text, that data type, is a string. So if I say string first name, and then assign it, let's go ahead and say Tom. Now strings are identified by double quotes around it. Notice how with my integer I didn't need any quotes around it. That's a number. If I put quotes around this, 30, if I did 37 right there, that's 37 as text, not 37 as a number because of the double quotes, meaning I couldn't perform arithmetic on that unless I first converted it back into an integer. Let's go Tom for now, and we will print that out. Save that and play. You can see we get 37 and then we get Tom. So again, just to reiterate, we have the type, the name, and the value. Anywhere that I refer to the name of the variable, it's just a placeholder for the value that that variable is holding. So variables are nice. They help us hold data and move it around. Like I could say string another name equals first name. So I'm assigning a new variable the value of first name. So if I printed out that, I would get same thing. So another name, run that. 37 Tom. So you can see how you can pass the values around between variables. And that's great, but it's not super useful until we talk about operations, performing some kind of statement or expression. And in order to perform any type of operation, we need an operator. So an operator is a symbol that takes two operands, and the operands are going to be a variable on either side, and it does something to them. So an operator that you guys may be familiar with is less than. If you've ever seen a statement like 6 is less than 9, that's true, right? We can see, we know that 6 is less than 9. The way that this operator works, this less than operator, is it evaluates 6 and 9 and their values, and it says if 6 is less than 9, then this is true. See, we have some chats here. Let's see. So name and variable are the same. Let's take a look here. So the name, this name right here, is the name of the variable, right? So age is the name of this variable. Anytime you refer to age or that variable, that's the name of it, the value gets put in place of there. So age or the name of the variable is the placeholder for the value. So every variable will have a type, a name, and a value once you assign one a value. So when you refer to the name or that variable, the name of that variable, the value takes its place when it's ran. Let's see. Good. Does that make sense? Correct. All three of these are variables. Age is a variable, first name is a variable, and another name is a variable. Age, first name, and another name are all the names of the variables. The values are 37, Tom, and first name, which is Tom. All right, good. So let's take a look here. So operators, let's see how this can work. Let's start with, actually, here's an even more familiar operator you guys are used to, anyone is used to. Let's say 3 plus 6. The plus symbol in math is an operator. It's an addition operator. What it says is take two operands, so the 3 and the 6 are the operands in this case, and add them together and return the sum. So 3 plus 6 equals 9. This is an operator. And it works the same way in C#. So let's try console.writeLine. Let's try that same one. 3 plus 6. So if I print this out, run it, right there you can see that it printed out 9. So the addition operator added the 3 and the 6 together and printed out 9. Now what if we wanted to use variables for that? So let's go ahead and say int number 1, or let's call it first number, second number. First number equals 3, int second number equals 6. Now instead of adding 3 and 6 together, we'll use those variables. So first number, the addition operator, and second number. So again, these are variables. They're placeholders for their values. The value of first number is 3, so 3 will get placed there instead. The value of second number is 6, so 6 will get placed there, and it should print out 3 plus 6, which is 9. So let's take a look. Again, it prints out 9. So good. Some other operators that we have access to, other arithmetic operators, include subtraction, addition, multiplication, division. Those are the main ones there. And mod. Now we'll stick with that. So I can perform any of those operations between two different numbers. Now, what if I'm working with strings? So I've got string first name equals, well, I've already got first name defined up here. So first name is up here, it's equal to Tom. Let's go ahead and define last name. So string last name equals, make sure that's camel case for convention, Sawyer. Now, if I have an addition operator here, so let's go console.writeLine. We can say first name plus last name. We'll save it and run that. What that does is the word we use is concatenate. It concatenates or adds those strings together. Now, if you're looking at that, you see there's no space there, which is kind of weird. So if we wanted to put a space there, we would simply concatenate a space to first name and then concatenate last name to the end of that. So we're adding or concatenating a space in between those two variables. So when we run that, you can see there's now a space there. So anytime you're dealing with strings and using the addition operator, it becomes a concatenation tool. So you can connect strings together or add them together. You can do the same thing with numbers. So I could say plus, add a space there, is plus age plus years old. So what I did is I said first name plus a space. So there's a space between the first name and the last name. Then plus space is space age years old. So this will print out Tom Sawyer is 37 years old. Let's run that. There we go. So the value and the benefit of variables is that they can be assigned anything programmatically and then used. So right now this says Tom Sawyer is 37 years old, but you could change up any of the variable values and it would print out, you know, what that variable now holds, which becomes it becomes very valuable when you start creating applications. Think about something like Facebook, where you have information that you're giving it, like your birthday, or so that all your friends know when it's your birthday. Well, that's a variable. You say my birthday is whatever day it is, and then because of that variable, it will show up on your page, but it's different for each person. Hence the name variable. It changes. All right. Can everybody hear me?
Yep.
Everything's coming through? Okay, good.
Sounds good.
Just want to make sure. Perfect. All right. So do we have any questions about variables right now, what I've gone over so far? Okay. Awesome. All right, so let's talk about Boolean logic. Then this extends upon the operators. So a Boolean means true or false. It will return true or false. So operators that are used in Boolean operations include things such as greater than, operators, greater than, because that's going to return a true or false. Either the left operand is greater than the right operand or it's not. Less than, greater than or equal to, less than or equal to, or if we use a double equal sign, that is a equivalence operator. Now before you saw a single equal, so when I did something like this, int age equals 12, this single equal sign is called an assignment operator. It assigns a value of 12 to the variable age. Double equals is what we use to check if something is equal. So, for example, if I say console.writeLine, 3 is equal to 4. We run that. It returns false. So this statement right here, 3 is equal to 4, is the same value as false. So just to expand on that, so we just said this is equal to false, so let's test if it's equal to false. True. This and this are the same thing. This returns false, and that's really important to recognize as we move on. So another few things we can check out. We could say 5 is less than 8. That will return true. 5 is less than 1. That will return false because 5 is not less than 1. 5 is less than 5. What do you guys think that will return?
False.
Why will that return false?
Because 5 is equal to 5.
5 is equal to 5, right? So we could do this, or we could say less than or equal to. So that would return true. And let's see, Scott pointed out that a hexadecimal value for space can be used instead of the space as well. Scott, do you know what the hexadecimal value for space is?
No, I don't, but I can look it up.
Okay, no worries. I don't know it off the top of my head. So yeah, that's why I use space. That's what I've seen in a lot of code.
Well, I was just curious.
It can. So in Visual Basic, I don't know if you've written code in Visual Basic or if you're familiar with that. It's used there a lot for your concatenation. It's like ampersand. I can't remember the rest of it though. But is that why you brought that up? Just out of curiosity?
Yes.
Yeah, perfect.
Yeah. Because a lot of this C# is like very familiar to Visual Basic.
Yep, they're both Microsoft products, Microsoft languages, and C# is, I mean, it's a different language altogether, but it follows a lot of the same principles as Visual.
Yeah, I've noticed that, and that's why it's making it a little bit easier for me.
Good, good. All right. So with Boolean logic, anything that's true or false, that's pretty, I mean, that's cool, that's useful. But the real use comes in when we can tell a computer or a program to make a decision based off whether something is true or false. For example, let's come here and say int Sally's age equals 19. Int drinking age equals 21. So we want to know if Sally can legally drink. So that's where we can use a Boolean expression with the keyword if. We'll check an expression. If the expression evaluates to true, it will then allow the following code to execute. So if Sally's age is greater than or equal to the drinking age, then we can print out console.writeLine. Else, if you can C# we need it right there, it's better. Else, WriteLine. So the if statement here will evaluate the Boolean expression here. If this is true, then the code within this block here, this open and closing curly bracket, will execute. If it is false, then the code here will execute. So let's see, is Sally's age greater than or equal to the drinking age? We can tell just by looking at it that it's not, so it should be false, and this should print. So let's take a look at that. So no drinks for Sally. So as we thought, this was false, and this printed out, and that didn't print. Now if we change that, it's a few years later, she's now 22. Go ahead and run the app. Sally can legally drink. So using Boolean expressions and conditionals such as an if statement, then we can tell a computer or program to make a decision based on the data that's given. So that starts to become very powerful. Let's see. Now, so there's an if and an else. An else will execute given that the if before was false. But what if there's more, what if there are more than just two choices? You can use either a switch statement, which we're not going to go over just for brevity's sake, but it's in the lesson. The switch statement's going to work very similar to your if statement. It just has a lot of different cases. But you can also use if, else if, and then else. So let's say, let's do a grade. Let's say int grade percent. I'm just gonna call it grade. So let's set grade equal to 81 for now. And then we'll say if grade is greater than 89, right line, if it's greater than 89, it's an A. Else if, oops, else if grade is greater than 79, it's a B. Else if grade is greater than 69, then it's a C. And then the very last one, I'm just going to skip D altogether. Else failed. So it goes through and it checks the grade, and if it's this, it'll print A. But if it's not that, then it's going to check the next one. Is it greater than this? Then print B. Is it greater than this? Then print C. And we have to do those in a specific order, because if we put this one first, it wouldn't catch it. If the grade was 90, it would say, is it greater than 69? Yeah, 90 is greater than 69, so it'll go ahead and print out a C. So we did them in this order so that it worked. Let's run this app and see what happens. We got a B because our grade was an 81. If we make that higher, let's go ahead and make it a 92. You can see that it gives us an A. We'll do one last one. 67. Failed. So any question about the conditional and kind of how it works? You have your if statement. You have a Boolean expression, something that returns either true or false. And then you have the block of code that it does there. So you can do multiple things within the block. You can do things here, 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 and like you can add as many lines of code as you want just between the opening and the closing brackets. If this is true, it will execute all the code in there. All right, let's talk about a little more advanced Boolean logic at this point. Let's say we need to compare two things, not just one thing. So let's see. What's an example we could use? When I try to think of something, I can't come up with anything. Let's just say we want to find a number that is, okay, a user can enter their age. So we want them to be able to enter an age between 1 and 100. We don't want them to enter 0. Let's just say, let's just say a number between 1 and 100. It's not age. We want users to make a guess between 1 and 100. So we have to check for two things. We have to check that the number they entered is greater than 1 or greater than 0, and it's less than 100. So to check that, we could do something like this, int number. This will be the number they entered. So number entered equals, let's just say 78 for now. So we can say if number entered is greater than 0, and you use double ampersands for this, and the number entered is less than 101. We could go ahead and acceptable input. Otherwise, it's not acceptable. Valid input. Right, so this will check this Boolean statement and this Boolean statement. An AND operator means that both statements must be true in order for it to work. So it has to be greater than 0 and it has to be less than 101. If either of those are false, the whole statement together returns the value of false, meaning this doesn't get executed, rather the else statement gets executed. The opposite of AND is an OR. And OR, it checks for one or the other. For example, let's say you can only, see. Let's do this. Boo has good credit equals true. So bool is a Boolean, that's a data type. So we can just set it equal to true or false, or we can set it equal to an expression that returns true or false, a Boolean expression. Let's say int down payment. It's $10. So you might have a statement that says something like this. If has good credit, I'm going to spell this out the long way, and I'm going to show you the shorter way to do it in a minute, but just so that it's very clear to everyone. So if has good credit equals true, or down payment is greater than 5,000, then we'll go ahead and say and buy the car. Else all right. So here we have an OR. So if has good credit equals true, or down payment is greater than 5,000. So we're checking not for both of them together. It doesn't have to be good credit and over 5,000. It's just one or the other. If either of these is true, either of these Boolean expressions evaluate to true, then the whole expression together is true. So right now the down payment is clearly not over 5,000, but has good credit is true. So it would print out the true on that. So you can buy the car. Yes.
Isn't that a short circuit or?
It is a short circuit or.
Okay.
So this will not actually get evaluated here.
Right.
Because this is already true. And we can talk about, we can talk about short circuiting in just a second. It's a little bit above the scope of this lecture, but we'll talk about it just so that everyone can be aware of it at least. So now I have this spelled out as has good credit equals true, which evaluates to true. And when I first started talking about Boolean expressions and how they equal true or false, there's no reason to spell this out all the way to if has good credit equals true. We can just say if has good credit. This is already a Boolean value, whether it's true or false. So now this is true and this is false, but this is an or, meaning it will be true, false. Since this is an or and one of them is true, the whole statement together evaluates to true. So if I run that again, you can buy the car, it is true. Now if I change this to and run it, it says no. Because and requires that both operands be true. And while the left operand is true, the right operand is not true. And it's just like regular English language. If you tell someone, hey, you need to give me $5 and a candy bar in order for me to give you whatever, my bouncy ball, whatever the second grade kindergarten trade is, you're asking for both. I need this and this. They both have to be true, have to be given to you. If you say you can give me $5 or your Pokemon deck of Pokemon cards, you're asking for one or the other, correct? So it's the same thing here. Double ampersand is and the double bar is or. Or asks for one or the other, and asks for both. So let's talk about short circuiting real quick. So you can use either 2 ampersands or 1. The difference being that the double ampersand, and it's the same with the bars, double ampersand and double bars are short circuiting, meaning if the evaluation is going to prove false right away, or true or false depending, false if it's and, true if it's or, it will just stop functioning right then. For example, if I have something like this, something equals, let's say, false and true. Because this is false and this is asking for them to both be true, it will read false and it will automatically know, hey, there is no way possible this can evaluate to true because I already have a false. So I'm just going to stop right here and return false. So something will be equal to false. If I use just 1 ampersand, it will evaluate both of them. It will still be false that gets returned, but it takes that extra step of computation to evaluate this as well. Now, with it being just true and false, it's not a big deal, but sometimes you could actually have, you could have a method there or a function that does a lot of work and returns true or false. And if the first one returns false, so like, let's just say you have a method is, actually, let's give an example of this. Is greater than 5, is less than, actually let's call it, I don't want to get too much into this, is less than let's call it 3. Pass in something here, int 6. We will pass in our number here, pass in our number here. Let me define these methods real quick, and we're going to be going over methods in the next lesson, so don't worry if this is a little further and kind of beyond scope because we'll be covering it, but at least you'll have some exposure to it. So let's go ahead and say static Boolean is greater than 5. It takes an int number and it's going to return the number is greater than 5. So that'll either be true or false, but before it does, actually we'll just go ahead and say if number is greater than 5, print out greater than 5, then we'll return it. And we'll go ahead and create another one of these called less than 3. is less than 3. As long as this is less than 3, then we will print out less than 3. Return number is less than 3. All right, and then we will go ahead. I got some. There we go. And we'll go ahead and print out Boolean. So console.write line something. All right. So let's start with the double ampersand here. We'll run that. So it went out and said, wait a second, is greater than 5 number. So it went ahead and it printed out is greater than 5, and then it printed, so that's right here, is greater than 5, and then it printed out false. Now it printed out false. Let's see, what is greater than 5 and is less than 3? Why didn't it? Oh, it never got there. Whoops. That might not be the best way to show the example. Let's remove this. Sorry, give me just 1 second. It didn't print this out because it's not less than 3, so it's not going to print it out. All right. Whoops. So if we run this now, it prints out greater than 5, less than 3, false. So it goes ahead and it prints out both of them. Now if this were an OR, it'll still print out, should still print out both of these because it's checking that first one first. Oh, no. So it only prints out 1 because it's greater than 5. That is true. It's asking for one or the other. Because this is true, it automatically returns true and just stops. So this doesn't even get called. So that's short circuiting. Now, if I change this to just 1 line and run it, it calls both of them and then still prints out true because this was true. So that's the difference between a short circuiting operator and a not short circuiting operator. That's something, like I said, that's a little bit above and beyond the scope of this lecture. So if you're not grasping that fully right now, don't worry about it. Just kind of know it exists. You'll pick up more of that later, but that's not the vital piece of this lecture. All right. So let's talk about the last piece, loops. So loops are used for when we want to perform an action a certain amount of times, whether that's a known number, a given amount of times, over and over, or if it's until something is something happens, then exit out of the loop. So for example, if I wanted to print out the numbers 1 through 10 without writing console.writeLine1, console.writeLine2, 3, and so forth, I'd want to use a loop for that. So I can do something, there's a few different types of loops. There's a for loop, a while loop, a do while loop. So if I wanted, I could do a for loop and I could say for. Now the for loop has the signature of the for loop has 3 different parts. The first part inside of these parentheses is the initialization of any variables. Usually it's a counter of some sort. And I is the common number. So I equals 0, the common letter, variable name used for it. I equals 0. The second portion after your semicolon there is the expression, another Boolean expression to evaluate. And you will continue looping as long as the evaluation is true. So let's say I is less than 10. And then the final piece is usually an incrementer. It's what to do after the loop has occurred, after it's iterated. So here I could go ahead and say console.writeLine I. So what's going to happen here, I starts out at 0. As long as I is less than 10, it will go ahead and execute this code, and then it will increment I. So I would now be, well, it would have printed out 0 because I is equal to 0. I is now 1. Is 1 less than 10? Yes. So it'll print out I is 1, so it prints out 1. It then increments, I is now 2. Is 2 less than 10? Yes. It prints out 2. Increments, is 3 less than 10? Yes, and so forth. So let's play that so you can see. Oh, it closed because I need a read line here. So that'll hold it open. There's the loop. Prints out everything through 9. Now, loops are useful, like I said, for repeating code, but something very common that you could see is, let's say you're working with a file. You could use a while loop to do this, and it says, while there's a next line, another line to the file, read that line and process the text. So it'll loop through and it'll say, is there another line of text? If so, go ahead and process it and do whatever you want in the processing. Then check, is there another line of text? If so, do the processing. If not, the loop ends so that it's evaluated to false. Is there another line? False. Another great example of something that you can use a loop for is iterating over any type of collection. We'll get to that more in the next lecture, but a collection or a list is something like, say a teacher has a list of students, and each of the students has a grade, and the teacher wants to get the average grade. Well, you can, or don't say the average grade, the teacher wants to print out each of the students' grade. You can loop over the students and print out each one of their grades. So anytime you have a collection of a bunch of objects or items and you want to perform some action on them, that's when a loop is very useful. So there's our for loop. I'll go ahead and create another loop here. We'll use a while loop. So for a while, it doesn't have 3 parts. It just has the 1. So while Boolean expression equals is true, then do something. So I'll go ahead and say, let's do this. Int k equals 0. While k is less than, well, let's do it this way. While k is greater than 0, we'll set k equal to 10. K minus minus, that'll decrement k. So let's run this. Oh, I didn't print out anything, so that's why nothing happened. Console dot write line, okay. And run. There we go. So there's our 10, 9, 8, 7, 6, 5, 4, 3, 2, 1. That's this loop right here. So you can see they kind of do the same thing. And it just really depends on what you're trying to accomplish. They each have different use cases, but that those are 2 of the most common loops. Yes, this is very much like JavaScript. A lot of programming languages you will learn as you study multiple languages. They carry over the same syntax. There might be minor differences, small tweaks here and there, but for the most part, when you learn constructs such as loops and variables and functions, methods, those concepts can be very easily transcended and carried over to other programming languages. So once you learn one, it makes it increasingly easier to learn another. Now they have different libraries. You know, they have their own, like in Java, you don't use console.writeLine, you use system.out. And it's not part of this, so it's gonna give me a hard time. Out.println. That does the same thing in Java as this does, and then in JavaScript it's console.log. So these three things, this is C#, this is JavaScript, and this is Java. But they do the same thing. And the syntax for a loop or a variable, they're very similar. So does anyone have any questions about anything we've covered?
Nope, seems pretty straightforward.
Cool. Let's see here, make sure there's no questions in here. Question, that while loop, let's say it was an infinite loop for some reason, but forgot to type out the console right. Would it still run that code and crash? Let's take a look and try it out. That's the cool thing about code is you can always mess around with stuff and make sure and just try things out. So let's say we want this to be an infinite loop, but on accident, or no, we don't want it to be an infinite loop because you really don't want an infinite loop, but I accidentally typed in the wrong character and I said, same character. I forgot to decrement it, okay? So while k is equal to 10, while k is greater than 0, let's log out k. Let's write k. Well, since it's not decrementing, it will never be, this will never be false. It will always be 10 and it will always be greater than 0. So it will always run. So see how it just keeps on printing? It just never ends. And that can make things crash. Luckily enough, I can just hit exit on that. But if you have an infinite loop in like your JavaScript, that could cause a browser to slow down and crash. If you have infinite loops in your code, it runs long enough, you can get a stack overflow exception out of memory. Yeah, infinite loops are not good. So you always, the expression in any loop here, you always want to make sure that it terminates, that there is a finite and sure way that it will terminate. Does that answer your question? Cool. All right, last chance for questions. If there are no more questions, then I will see you all next time. And let me know. You can always message me, Slack, email, if you have any questions. Have a good one, everybody.
Yeah, me too.